we are doing angles of rotation, and that's where we're at. So let's zoom in a little bit and look at a couple of these examples. So so an angle of rotation, we always start right here. This is the starting place, the initial side. Positive angles go to the left. Negative angles go to the right. And so remember, 90 is straight up and down, 180 is halfway, 270 is 3/4 of the way, right? And 360 is all the way around. So we know that if we go all the way around, that's 360 degrees. Now these are positive angles. Negative angles go the other direction, down. So this is counterclockwise is positive, and go clockwise, that's negative. So this is negative 90. It's also positive 270. This is negative 180. It's also positive 180. Right? If you went this way around here, this would be negative 270. But if I only go this far, it's positive 270. So there's a positive and a negative answer to every angle. Right? Wherever you're at, there's a positive and negative angle that goes all the way around. So if we look at this, where's 300 degrees? Let's look at this one. 300 degrees, where's 300 degrees? Well, you start here, you always start here. And since it's a positive number, you go 90, 180, 270, and just a little bit more makes 300. All right? What about, where's negative 150? Well, remember, this is 90, and all the way across is 180, so it's got to be a little bit less than 180, right? That's what you're thinking. Look at this one, 900. Now watch what they did. Do you see the spiral there? They went around once, that was 360. They went around twice, that was another 360, which makes 720. And then they kept going until they got to 900. So 900 is the same as 180, right? Because it lands in the same place. Exactly. Okay. Look at this one. We need to be able to find reference angles. Oh, let's do this one. I'm sorry. First, this one. Find coterminal angles. So if I want to know where is 40, now you know 40 is right here. Right? That's 40. Now, if I wanted to know another angle that's the same as that, I could take 360, I could take 40 and subtract 360. That would give me negative 320. So if I went around this way, negative 320 would land right on it. Right? And if I wanted a bigger angle, if I wanted to know another angle that was the same size that was positive, all I have to do is add 360 to this. So what I'm doing is I'm subtracting 360 from it, and I'm adding 360 to it. Right? So here we go. If I add 360 to 40, I would land here. 400 degrees would land exactly on 40. Would land exactly on 40. Right? Because I've got 40 is right here. If I take 360, if I subtract 360, that would be negative 320. If I take 40 and add 360, that would be positive 400 degrees. See what I'm talking about? So what about 380? Well, 380 is all the way around plus a little bit more. All right? 380 is all the way around. So if I subtract 360, that would be 20 degrees. It's the same as 380, right? And if I go the other way, 340 is the same, negative 340 is the same as positive 20, which is what that one is, right? Yeah, that's it. Now, reference angles. Reference angles. Look at this puppy. So you know where 150 is. I want to know the reference angle is the little tiny angle that would live over here, right? So 180 minus 150 is 30. So that's called the reference angle. Negative 130. If I go this direction, how far away is it from the x-axis is what I'm asking. And so if I'm over here, how far away is it from the x-axis? It's exactly 50. So that's the reference angle. So what you're doing is you're measuring the distance, the angle that goes to the x-axis. So if I go 280, how far is that? Well, 270 is right there. So 280, if I'm doing I would have to figure out how far is it from the x-axis. So I would subtract from 360. You know, here I would subtract from 180. Here I would subtract 180. Here I would subtract 360. That's what I get. So let's look at this one. I already told you the answer. I'll cover it up. 105. Well, 105 is over here somewhere. Right? It's bigger than 90. So I take 180 minus 105. 180 minus 105, that's 175. How about 115? Negative 115, I would go over like this. So it's away from this angle here. So I have to do 180 minus 115. How far away is that? Well, that's only 65 degrees. How about 310? If I went all the way around here, 310's over here. How far away is it from 360? It's only 50 degrees away from 360. So it's easy to measure the reference angles if you measure from the x-axis and then subtract, right? Nothing to it. Let's see, what's the other thing? Alrighty, last thing is if I give you a point on the line, on the x and y axis somewhere, like the point 4, negative 5. If I go over 4, negative 5, 4, negative 5, right? I want to know if I built a triangle right there. See, it's 4 wide and 5 tall. 4 wide and 5 tall. If I built a triangle right there, how long's the hypotenuse? Well, I'd have to do 4 squared plus 5 squared. That's 41. So the square root of 41 is how long the hypotenuse is. Right? So how big is this angle? Well, I don't know. We don't know what the angle is, but we know what the sine is. The sine is 5, negative 5 over the square root of 41. We know what the cosine is because the cosine is 4 over 41, right? The cosine is the x value. The sine is the y value. Okay? Y over the hypotenuse, right? And then this one is adjacent over the hypotenuse. And this is opposite over adjacent, right? So when you're in this quadrant, the angle down here, the sine is negative because the y value is negative. The cosine is positive because the x value is positive. And the tangent is negative because it's negative divided by positive. That's all we're doing. Yay! And look, we've got the cosecant. That's the reciprocal of this guy. The secant is the reciprocal of cosine. And then the tangent is the reciprocal of this. So when you do reciprocals, if it's negative to begin with, it's negative when you're done. Right? That's what we're looking for. Exactly like that. Exactly. So Let's do a couple. What do you say? Let's do a couple. So here we go. We're going to do one like this. Where's my point here? Okay, we can just write it on this. That would be lots easier, huh? Let's write it on this. Okay. Here we go. So if I had a point given to me, and the point was 2, 5. 2, 5. All right. So here's my angle, right? If I go over 2 and up 5, that's where that would be. So I'm building a triangle, right? This is 2, this is 5. How long is the hypotenuse? That's my question. Right? How long is that length right there? Well, I know 2 squared plus 5 squared, that's 4 plus 25, that's 29. The square root of 29 is the hypotenuse. Right? So, if I'm talking about this little angle right here, which is what I want to know, what is the sine? We'll call that theta. What's the sine of theta? Well, the sine is the opposite over the hypotenuse. So that's 5 over the square root of 29. Right? Cosine is 2 adjacent over hypotenuse, 2 over the square root of 29. And tangent is opposite over adjacent, 5 over 2. Right? Now, if I wanted to know the cosecant, that would just be 29 over 5. The secant would be square root of 29 over 2. And the cotangent would be 2/5. Right? Yeah, that's what we do. How about that? So there's nothing to it. That's what we want to be able to do every single time. Right? Let's try another one. Let's try one like this, where we've got an angle given to us. So let's do angle negative 165. Where the heck is that? Remember, you always start here, and this is 90, and this is 180, so 165 has to be away from there, right? Woo! 165 is that angle, negative 165 degrees. Right? What's this angle? How far is it from 180? Well, that's easy. 180 minus 165, it is exactly 15 away, right? 15 away, that's all you do. So, the reference angle, this is called the reference angle. The reference angle is an angle that would land between 0 and 90. So it has to be a small angle. And once you know how big that is, then that's the answer. What's the reference angle? We got it. We got it. What if we wanted something else instead of the reference angle? What if we wanted to know a positive angle that had the same endpoint right there, right? So that means we're looking for the guy that starts here and goes this way. How big is that guy? Well, heck, I know exactly how big that is. Since I know what the reference angle is, all I have to do is go over 180 plus 15, and I'm going to land on the same place, right? So 180 plus 15 would be 195. 195 would land on the same line as 165 negative. These guys land in the same place, right? Now, believe it or not, that means the sine of 195 is the same as the sine of negative 165. And the cosine of 195 is the same as the cosine of negative 165. See, these angles land in the same place. That means the sine, cosine, and tangent are all the same. Always, always, always. Always, always, always. Right? These guys are all the same. If you know what the positive angle is, the negative angle is, and the reference angle, you got it made. I think that's enough for today. See ya later.